All right, what's up, guys? In this video, we're going to pick up some calculus here. It's going to be another integration practice video. It's going to evaluate the integral x squared times sine of pi x dx. So to evaluate this, we should probably apply integration by parts. Remember, the formula for that is the integral of u dv is equal to uv minus the integral of v du. We need a u and a dv, so let's get that. In this case, let's select u to be x squared, and let's let dv be everything else, obviously. So dv will be sine of pi x dx. So we know we're going to need du, and we're going to need v. Also notice that this is an x squared. So we're going to have to apply integration by parts twice to evaluate this. Remember, we've talked about this in previous videos before. You can easily identify when you're going to have to do by parts twice for most cases. And we're going to have to do it twice, because once we do it once, it's going to drop the power of the x down, and we have to do it again. So let's take the derivative. So we'll get 2x dx. And then v is the antiderivative of dv. So we want the antiderivative of sine of pi x dx. And remember, that's just negative 1 over pi cosine of pi x. Make sure that you can compute your v's relatively quickly. For the most part, with integration by part, the idea is to pick something to be dv that isn't difficult to integrate. So most of the times getting v is relatively simple. Integrating something like this just requires a simple substitution. So just make sure that you can compute those relatively quickly. If you're having trouble computing the v, then you either probably made the wrong selection, or you may need a little bit more practice in your integration. So you want to make sure that you can compute that quickly, so that way that doesn't get into the way of you being able to finish the rest of the problem. Because sometimes it can take a little bit of time to get v if you're kind of rusty on the integration thing. But that can always be worked on. So let's go ahead and use the formula here. So I'm going to write this side as negative 1 over pi x squared. It's going to be cosine of pi x. And remember that multiplication is commutative, so you can kind of write this side kind of any way you want to, believe it or not. And then if we do v du, well, we're going to have two negatives. I can factor out a 2 over pi. Remember that pi is just a number. It's just a constant. It's 3.14. I don't even know what the rest of the numbers are, but it's just a constant. And then on the inside, we'll have x times cosine of pi x dx. And so as you can see, I'm going to have to do integration by parts again, just like I told you. So let's do it again. And let's not deviate from the selections that we had the first time. So let's let u be x, and dv will be cosine of pi x dx. So we just need the u, and we need v, which is the antiderivative of dv. Again, make sure you can compute these relatively quickly. You don't want this to get in the way of getting the problem done. So in this case, that's just positive 1 over pi sine of pi x. How do I know that? Well, if I take the antiderivative of cosine, just cosine of x, for example, let's just say respect to x, I know that's positive sine. So in this case, again, to get this, you just do a substitution. So I know this is going to be positive 1 over pi as opposed to negative 1 over pi, because I know if I take the antiderivative of sine of x dx, I'll get negative cosine of x. So you want to make sure you compute those quickly. Now we go down to, and we do our by parts. Again, whenever I'm doing by parts twice, I don't connect them immediately. I always kind of do the second integral first, give you what the antiderivative to that first integral or the second integral would be. And then I go back and connect it, because if you're connecting things too quickly, that tends to get a little bit confusing for students. So we got 1 over pi x sine of pi x. I can factor out a 1 over pi, It's just a constant. Then I got the antiderivative of sine of pi x dx. And a lot of times with these by parts that you have to do twice, it just seems like you're running around in circles, but just keep going with it. Now, you already know what that is because we got that up here. That's going to be negative 1 over pi cosine of pi x. Now remember, there was a negative 1 over pi on the outside, so I'm going to go ahead and multiply that through. So we got negative 1 over pi times negative 1 over pi cosine of pi x. So this gives me positive 1 over pi square cosine of pi x. Now if I were to do the second integral, what I would end up with, and we'll connect it after I do this, I would just end up with 1 over pi times x sine of pi x. And then this would be plus 1 over pi square, and it'll be cosine of pi x. So technically plus c, but that's what we would get when we compute the second integral, which was this one here. Now we go back and we connect it. And you don't have to do it the way that I do it. I always say, as long as you're getting this correct answer, when you're doing problems like this, if you're doing integration problems, however you go about doing it, whatever way works best for you, is fine. You know, so if 2 plus 2 is 4, if I get 2 plus 2 is 4 one way and you get it a different way, as long as we're both arriving at 4, I don't think it's a big deal. So we're going to connect the first by parts to the second one. So we got negative 1 over pi, negative 1 over pi x squared. Remember, that was the first one. And it was cosine of pi x. And then it was going to be plus, right? Remember, there was a 2 over pi. So it was a 2 over pi, or positive 2 over pi. And then we'll connect that to the second by parts, which was positive 1 over pi x sine of pi x. And then this is going to be plus 1 over pi square cosine of pi x plus c. And you don't want to leave things that way. I'm going to go ahead and distribute in, kind of expand everything out. And there's no reason to write all that down at one time and then write it all over again. So we'll go ahead and just write our final answer. And all I'm going to do is expand out and distribute in this 2 over pi. And, you know, we don't have to touch that side. So we're asked to integrate x squared times sine of pi x dx. All right, so it looks like our answer is just going to end up being negative 1 over pi x squared cosine of pi x. And we're going to distribute in. So if I distribute in, it looks like I'll get plus 2 over pi square x sine of pi x. 2 over pi times 1 over pi square. That's going to be plus 2 over pi cubed cosine of pi x. And don't forget to tackle on that plus c. And that is your answer. Okay, so that's how you do it. So hopefully I was able to provide you with a little bit of insight into the whole process for this one. Again, this one was a little bit involved, but I don't think it was too difficult. Sometimes integrals that can take a little bit of time, they aren't necessarily difficult, they just take a bit of time. That's all. So let me know what you think. So I'll see you guys next time. Let me know if you got any questions, and y'all take care.